So the first thing we want to understand is what is software engineering and who is a software engineer. And a software engineer is just a person who combines computer science and engineering principles to build efficient and secure software systems. And the software engineering is a process or an approach, a measurable approach of creating or designing, developing, testing, deploying, and maintaining software systems. And so for you to be a software engineer, you have to be able to use this systematic approach, combine engineering principles along with computer science principles to create systems that are more efficient and scalable and reliable also. Now, software engineers and software developers, they perform similar tasks, but their differences is more on the mindset. While the developer might not combine engineering principles, the software engineer will do that. So sometimes we find them used interchangeably, but the fundamental difference is mostly in the mindset of the developers, the focus, and the approach to which they do things. Now, IP is another acronym you will hear, which stands for Internet Protocol. And Internet Protocol is just the unique address that is assigned for each device or each computer on a network. And this unique number is always a kind of code, like you see things like 192.168.1.1 for home routers. These are IP addresses. And if I tell you log on to the classroom, the IP address of your classroom is 54.198.1.2. It's not a name. It's not an address that you want to type in your browser window. So what you want to do is to name this IP. And that's where you have things like facebook.com. When the server is created, it has an IP address. A server is your computer or a device over a network. It has an IP address allocated. We go to our domain name system and we name this IP. And so anytime somebody types facebook.com, it resolves to the IP or the unique address and locates the system that you're trying to reach. We have an acronym HTTP, which stands for Hypertext Transfer Protocol, and it is used to transfer web pages and other resources over the internet. So every time you want to do a Google search, for instance, when you type google.com, HTTP is the protocol before you find like HTTP google.com. But HTTP is not secured, and with modern browsers now, what you'll find is a security warning that there is no encryption, or you're attempting to connect to an unsecured site. And so for that, we have something called HTTPS, which adds a layer of encryption to the HTTP. So it encrypts the data between your browser and the server you're trying to reach using SSL or TLS. And we're going to look in details on what SSL security is in another course when we do domain name system and the likes. So when you have HTTPS, it means that your connection is secured, and it ensures that there's a privacy when you're searching or when you're logging in. Another thing you commonly hear is tech stack. Now, tech stack is the combination of all the technologies that you use to build or run your application. So it involves your programming language that you use. If you use framework, your frameworks, and all the other tools that you use is your stack. So when you are asked about your tech stack, you want to list the programming languages or your frameworks and your tools that you combine together to build an app. Then we have DNS, which is the domain name system. And what the domain name system does is to translate domain names into IP addresses. Okay, and so when we talked about IP address a while ago, we talked about how to name those addresses to have beautiful names that you can easily type in your browser window, and then that name resolves to the unique IP address of the server or the system you're trying to search. Now we have the VPN, which is Virtual Private Network, and it's the service that encrypts your internet connection. And when you encrypt this, it marks your IP address. So when it does that, your privacy and security is ensured. And one of the common uses of VPN is when you are trying to go to a website that is restricted in your country, and you decide you want to use a VPN so you can connect to that service or that system or that app or content. And there's some apps that are built with extra security that will know you're using a VPN and will still try to find where you are coming from. All right, so we have brute force, which is just a hacking method that the hacker tries to use all exhaustive list of passwords. They can try thousands of passwords to break your password. And so that is why you are always advised to choose a secured password, not something that can be easily guessed, not a word, not your birth date, and things that people can easily guess and say. They know the names of all the members of your family, so let's try the names one after the other. They know your favorite vacation spot, and that is your password. It becomes a problem. So there are different ways of choosing a secured password, and sometimes the bad guys do not sleep, so they have things like bots that they use to keep trying endlessly, and they can try millions of combinations until they get one to be able to hack into your system. And so the more difficult the password, the more the key combination will take hundreds of years, which will not be possible now for a hacker to get into. So you always choose a secured password. What I like to do is to write a whole sentence, put it backwards, switch it, and use it as a password. And it's a sentence that I will remember. And it's a sentence that the bot or whoever hacker will need 200 years or more to be able to reshuffle to get my real password. So we have another term, social engineering, that you will always hear about. And social engineering is a manipulation technique that hackers or bad actors use to deceive people or trick people into what they are not, to believe that they are what they are not, so that they can get information or get access to their systems. So one type of social engineering attack we have is when you receive phishing emails and you're asked to click on the link for you to be able to do something or to be able to dispute something, and then so that's why you don't click on links in an email that you don't trust the domain or you don't know. You always want to look at the domain of the email and make sure it is a domain where you expect such email to come from. Sometimes there's this trick they use, like domain fuzzing, where they change the words around. So for instance, your domain is mildredgroup.com, and then they use mildredgroup.co.co and create a name, like a mailbox with a name of somebody that actually works in the company. So you have an IT staff called Sam, and you have sam.mildredgroup.com as your IT support staff. When you look at the email signature, it is coming from sam.mildredgroup.com. You feel okay that this content is secured, it's coming from internal. But a hacker can manipulate you into using something sam.mildredgroup.co, and you won't pay attention to the last M that was removed. Or you look at the Mildred group and maybe L is not going to be there. The registered domain creates mailbox. A random check, your mind automatically completes the missing letter. Is hard for you to see that. And then you trust that the domain is correct, and you will give the information that they need to get access. Or sometimes you click on the link in the email thinking that it is an internal link, and you end up installing malwares or keystroke loggers on your system. So we have cryptography also, which is the practice of securing data through encryption or encoding. And so by the time you encrypt your data, only authorized parties will be able to read it. And so we use this severally in so many things where we have end-to-end encryption. And if you have a hacker looking through or intercepting your communication, they can't even decode what is that, because only the person receiving the information can decrypt and understand, and only the person sending understands. So in between, nobody understands. All right, so we use codes that are not plain text to translate the messages. And so we'll see that in our full stack courses, where we have AES encryption on our data to de-identify sensitive information or sensitive personal information. All right. And you also will hear about CI/CD, which stands for continuous integration and continuous deployment. And this is just a development practice, operation practice, where we automate all of the software testing and building and deployment. And we have tools like GitHub. And if you take that free course for command line Git and GitHub, you will see how we use GitHub as our source code repository, and we have GitHub Actions that we can use as CI/CD tool to automatically test and deploy applications. We talk about algorithm also, which is a step-by-step procedure to solve a problem or to perform a task. So if you want to bake a cake, for instance, you need to have a recipe, right? That step-by-step process of what you combine first, at what time will you beat the eggs, or what time will you mix that, how many minutes will you spend in the oven. This is a step-by-step process, and this is an algorithm. All right. But in the case of computer science, when we have a problem to solve, the step-by-step process you will follow to solve that problem is called the algorithm. And so we have different kinds of algorithm. And if you take the course Fundamentals of Software Development, that is the course that you should take if you want to try technical interviews, because everything you learn in that course are the exact type of things that you'll be asked in any remote job interviews. And it will look critically at data structures and algorithm in that course. So data structure is that way that we use to organize and store data for efficient access and modification. When you want to store your data, you want to look at what is the most efficient way. How do I get this data back when I need it? And how fast can I retrieve this data when I need it? That organization, or that way you store that data to easily get it back, is called a data structure. Now, we use this data structure and algorithm all the time, and data structure particularly is like, let's take an example of our family tree, for instance. And most of us had a family tree when we were in elementary school. We were asked to draw a family tree. And on that family tree, we'll see things from our great-grandparents, our grandparents, our parents. And on one branch of the tree, it's everything that led on to how we were born. On another branch of the tree, we'll have all of our aunts and uncles and grandparents and their own siblings. And we'll have a whole tree structure. And then you can now look through that tree. And if you want to identify who is the mother of John, and then you look up the tree and you see where John came from, his lineage on that line. So that organization of your information is called a data structure. A family tree is an example. Okay, so we'll talk about recursion also, which is just like in programming, when you talk about recursion, is you are defining a function. And then before you finish defining the function, you call the function within itself to solve another part of the same function. We call that recursion. And also in the course Fundamentals of Software Development, we look deeply at all of this. We have other commonly used words, browser, which is like your gateway to the internet. And whenever you open anything like Google and you try to search, you are in a browser window, right? And we have 5 major browsers. We have Google Chrome, we have Microsoft Edge, we have Mozilla Firefox, we have Apple Safari, and we have Opera. There are several other browsers, but these are the 5 major browsers. And so when you begin to create your software or develop your web pages, you want to make sure that they are responsive across the 5 major browsers. Then we have something called the server, which is a system that provides services to other systems over a network. So if you have Office A and Office B has a computer there that has all the files and folders about all of the work you're supposed to do. Now in Office A, you have your computer. You don't know what you are supposed to do. You want to get that information from Office B computer over the network. You want to search Office B computer. Now when you go to your browser window or you go to your file system and you try to search Office B is the server that is providing a service to you. Office B is the server that holds the information you want and that you can search to get the information. That is called a server. In terms of web pages and software development, we always have a server, whether on-prem or on the cloud. We have a server where we store all our web files and where we make it available over the internet so people can come and search facebook.com and it gives them the Facebook homepage, which is the server. You click on login, it gives you the login page. Now, the communication between your system and Facebook is a communication between your system and the server that holds the files and all the directories for the Facebook app. Now we have a command line, which is a text-based interface that will allow you to interact with your system. You can look at the different file structures, the different directory structure you have. It is something you need to understand if you want to be a software engineer, because you configure systems, connect remotely to systems via your command line interface. And in next week's lesson, we're going to look deeply at command line and give examples on how to use command line. We also have a free course which starts in September that deals with command line, Git and GitHub, and which you are advised to take. It is free, it runs for 6 weeks, and it is a fundamental knowledge you need to have to succeed in the world of software engineering. Now, a software developer is a person that designs, builds, and tests and maintains the applications. We've talked previously about a software engineer, which is similar to software developer. It's just a difference of their mindset and how they do things. While the engineers have engineering principles and different computer science principles that they use to build systems, the systems are more optimized and they're more efficient because of those principles. While the software developer doesn't naturally use these principles, except that developer has works in a team of engineers or has the fundamental knowledge of engineering processes. And so the difference between an engineer and a developer is very subtle, that it is used interchangeably sometimes, and it's mostly in the mindset of the people we call developer and engineers. All right, so this is where we end this week's lesson. Thank you and see you next week.